Hello everybody, welcome to today's webinar focusing towards an increasingly popular 3D version of Sygic Professional Navigation. The webinar is intended for product managers and also for the developers integrating Sygic navigation into fleet management systems and other solutions. During today's webinar, we will explain different integrating possibilities of Sygic 3D professional navigation, as well as a very important topic, migration process from 2D to 3D version of the product. The webinar will be divided in two parts. The presentation that will take approximately 35 minutes and the Q&A session that we will leave open for a maximum 15 minutes. As usual, you are more than welcome to take an active part in this webinar by asking us questions. We will collect all the questions during the webinar and address them immediately in the chat tab. And for more complex questions, we will keep them for a Q&A session at the end. You can post your question in the chat tab that you can see on the left bottom corner of the screen or via email at webinar@sygic.com. There is no need to take notes. You can download the presentation from the left top corner of the screen anytime, and in the follow-up of this webinar, we will be sending all attendees the presentation and the recording. In case you feel that you need to discuss some of the topics that we will address today in more detail, please feel free to write at fleet@sygic.com or contact directly your sales representative at Sygic. Finally, I'm happy to introduce our presenters for today. Unusually, today we have two of them. First, we'll start Viktor Bielko, the head of product management. Many of you know him already, and he will open the session explaining all possible types of integration of Sygic 3D professional navigation. To follow, Radim Tmar, our business architect, and he will explain the migration from 2D product to 3D product in three types of migration. He will be also showing some examples for developers. Before we start with the presentation, as usual, I would like to open with a short introductory poll, and that will help us understand the audience today. So I open the poll and you are free to vote now. Okay, I will leave the votation open for a short while. I'm closing. And here we can see the results. So most of you, as we expected, has integrated 2D version of the Android. So probably the topic that is then the second part of the presentation will be interesting. Thank you very much, and I will leave the word to Viktor
now. Thank you. Hello, everyone. So, as Roman mentioned, we will be discussing the integration possibilities of the 3D navigation. With this webinar, we have the opportunity to present you new way of integration of the navigation, that is the embedded integration, which probably many of you have been waiting for. So, but about the agendas. First, we will start with all the integration possibilities of the standalone navigation. Then we will mention the new embedded integration. Then we will compare these two options, and as the last point, Radim will present the migration from 2D to 3D. So first, the standalone integration. This has more options of doing that. First is the integration with SDK. Many of you know this already. This is the standard functionality where the integrator includes an SDK, small SDK library into his app and interacts with the navigation as a separate process running on the device. There are over 60 API functions in the library that allow you to control this, and this is a two-way communication. So the navigation is sending also information back to the integrator's application, and there is the possibility to switch between the applications seamlessly from within your application. The second possibility of integration is the custom URL. This one is a little bit more easy to do, but of course has more limitation. In this case, the integrator doesn't have to include anything into the app. It's only the standard Android or iOS functions which are used. There are 10 simple URL commands which is possible to use, but of course on top of it, it's possible to use the standard Google or Android geo URL commands. In comparison to the previous one, this one is only one-way communication. That means that executing a command brings the navigation to the foreground, and integrator's app cannot get back to the foreground until the user does it. But to cover this, we have implemented new functionality into the 3D navigation, which is called the back button. This is a button that allows the driver to get back to integrator's application with clicking a single button, which is displayed on the map, so no need to go into menu, search for any buttons. This one can be initiated with custom URL command, or it can be defined in settings overload file. The next opportunity for integration is the sidebar. This one was designed for the landscape mode and was designed for solutions where it is necessary to display some information like text or pictures to the driver, and to have some custom buttons that the user can use. So this is another possibility to display some of the details of the integrator's application on top of the navigation. Then we have things which are probably new to you. The first one is head-up display API. This one was designed for connected car functionality, but it is available also for the integrators. The head-up display API is a one-way broadcast, so the navigation, when it's activated, the navigation is every time casting out the information which are displayed on the screen, and the integrator's application can listen to this broadcast and can use this data. The first use case for which was this designed was for producers of external head-up displays, but of course this can be used also in a fleet management product. There are customers who use this, for example, to retrieve the current speed limit on the road. The next integration possibility, also coming from the connected car, is the telematic broadcast. In this case, it is another application running on the device that broadcasts some data that are being read out of the vehicle, and the navigation can consume these broadcasts. The example integrations which we have done is the EcoScore driving, where the navigation visualizes these EcoScore on the screen, as you can see on the picture. Another use case is like low fuel warning or tachograph warning on the remaining drive time, where the application reacts on this and suggests to the driver to take fuel at the nearest station. So we have gone through the just briefly, but in case you are interested in more details, of course, we are open to get into the details of this. So we have closed the topic of the standalone integration of the navigation, and now we are going to do a short poll. So please vote now. Okay, a few more seconds for voting. Okay, now you can see the statistics. So it seems that many of you use the SDK already. Okay, now back to the presentation. So today we have the pleasure of presenting you the new integration possibility as an embedded element of your application. So in this case, you get the navigation as a library that you have to include into your project, and inside of your user interface, you design some surface in which you want to have the navigation displayed, and you integrate the Sygic fragment into this layout. The API functions of the SDK are the same as in the standalone SDK, but the difference is in the initiation, but this will be explained to you by Radim later. So this is, many of you know this already from the 2D navigation, so finally this is available also in the 3D navigation. Now we'll get to the comparison of the standalone SDK or standalone using of the navigation and the embedded integration. So there are significant differences. The first important difference is that in the standalone integration, your application and navigation are two separate processes. In case of embedded integration, both parts are in the same process. This has also some downsides, like for example, if the navigation crashes, it causes also crash of your application. So this is also to be considered. The next thing which is different is the installation. Many of you probably experienced already the installation of the Sygic 3D navigation. You know that this one is automatically installed and extracted from the APK file, and the application downloads the remaining resources and maps itself. In the case of embedded navigation, you have to integrate the navigation library into your project, install your application, and you have to manually deploy the resource file. Concerning the future updates of the navigation, the standalone navigation can be updated with APK or from Google Play. In case of the embedded solution, you have to rebuild your application with the new libraries, and you have to redeploy new resource files to the devices. With the update of the maps, with standalone navigation, there is possibility to remotely control the Sygic downloader of the maps from the server. In case of embedded integration, this automatic downloader is not working, so it's necessary for you to manually distribute the map updates. Concerning the remote license activation with standalone application, you can use the new business licensing system to remotely activate the licenses. This one will not be working with the embedded integration. And the last difference is the sharing of the screen between apps. So this is the only place where the embedded integration has benefits. You can split the screen between navigation and your application, where you can show additional components and buttons on the screen. And this is not possible with the standalone navigation, which is running on a full screen, and you have to switch between two applications in foreground in order to switch the data. So this is for the first part, the introduction of the integration possibilities and their comparison. Now Roman will come with a short poll, and then Radim will explain the migration.
Okay, so we closed the first half of our presentation. It was very swift. Thank you, Victor. And to introduce the topic that is coming next, which is the migration to Sygic 3D, the obvious question, if you plan the migration from 2D to 3D, you can vote now. Few more seconds for the voting. Okay, I'm closing the votation now. A short side on for the situation. So it looks like a lot of you doesn't plan, but the majority is still interested in moving. So Radim, please go ahead and explain how.
Okay, hello, this is Radim. So let me take over the last chapter, which is about migration details. This will be more developed oriented, but I will take it from a high level so that anyone can understand the principles and estimate the effort which is needed. I will discuss three types of migration, all, of course, towards integration of Sygic 3D for Android. And the first type of integration will be for those who use standalone integration and want to move from Sygic 2D to Sygic 3D. I will show this is really trivial. The second migration will be for those who have embedded integration already in place and they want to switch Sygic 2D to Sygic 3D. I hope I'll show that this migration is nice and sweet. And third migration will be for those who have standalone integration of 3D version and are thinking of moving to embedded integration. and I think this will be a topic which you might find challenging. Okay, so let me start with this migration when there is a standalone integration. So let me first start with a few comments or remarks. What is the standalone integration, such that we have a common understanding. So standalone integration means that you are using Sygic in a full screen mode, and which runs in a separate process, and you are building your application which is extending on these navigation features, and you completely design your own application on a separate screen. And so by means of, for example, a navigate button, you might call Sygic to open up or switch between the navigation screen and the application. What has been already said, we are with 3D version, we are introducing back button programming support, which Victor was saying, for easy switch between your application and the navigation. So here, let me show the programming pattern for standalone integration, which I show it syntactically informally, and I'll show it on the blank Android application, but the same would apply with any application you have. So in order to integrate Sygic navigation, your integrated application needs to do a couple of things. So I'll show it in the blue part. You need to define the extension on Sygic callback class, which inherently offers 3 methods: on service connected, on service disconnected, and on event. The important method is on event, which captures navigation events on which your application can react. So for example, through this function, you can receive passing waypoint event and you can react on that. Interesting might be also the on service connected, which notifies you that the connection to Sygic service after initialization was okay. If something goes wrong, it gets into on service disconnected function. So then on the green part, I show how you need to initialize and connect to Sygic API. So this is of course happening at the startup of the application, which here I represent with onCreate method, which you might know in Android world. This is the place you are defining the initial actions. So here there are 2 lines of the code, API init and API connect, which actually triggers the connection to the Sygic. And if it's successful, it ends up in the on service connected function. And in the brown part, I illustratively define UI function, which could represent the definition of your complete graphical user interface, which would exploit Sygic API calls like start, navigate to address, and get root status, etc. So what does it take to migrate to Sygic 3D? And as I said, it should be trivial because we keep the same programming pattern as I explained for the 2D. So the same will apply for 3D. Of course, we also keep the complete compatibility of API functions. So no need to redefine UI function, for example. The small change would need to be done on the API init function, where there is a parameter which defines the binding to a corresponding Sygic version, which is defined by package name. So for example, if you want to connect to Sygic 3D track, you need to supply the parameter com.sygic track, while with 2D it was something like com.sygic.drive. And as I mentioned, another remark is that you might help yourself help the integration using the back button feature. This can be done by configuration of the navigation or even programming using the Android intent way. Okay, so to summarize these migration type, the standalone integration, migration, so these are the few points which needs to be checked. So there is the change on the connection. So you go from with API init parameter, as I mentioned, to another parameter, and we have here 3 versions actually available. We have a truck, car, and taxi versions. So based on which one you want to choose for integrating, you will apply corresponding parameter. What you need to consider also that we have a new library which holds the same name, so you have to make sure that you really copy the correct jar file into your building process. What is not critical in this kind of integration, but I would like to highlight it, that we introduced the get SDK version function where you can retrieve the version of the API you have, which can help you make sure the things you have correctly integrated. Then we also introduced the new itinerary handling using JSON strings, so you have alternative functions for add itinerary, get route status, which operates with the JSON structures. And as I mentioned already 2 times, there is a back button control which you can use to improve your design. Okay, so that was the first type of migration, and based on the polls, I saw that this was probably the most important for all of you. But there was, in the poll, I saw that some of you are having also embedded integration on the 2D and are thinking of migrating to Sygic 3D. So this is the second part which talks about that. And as I mentioned, I hope you will find this migration nice and sweet. And so first, let me give you a few remarks, general remarks. What is this embedded integration? To have that we are on the same line. That was already actually presented by Victor, but I'll rather repeat it again. So this kind of integration means that Sygic navigation is rendered in a predefined Android layout element, and it occupies just the partial screen. The rest of the screen can be available for your application design, so the B part. And Sygic navigation runs within your activity. It's the same process. So here I show the programming pattern for embedded integration using Sygic 2D. So for those who already use this kind of integration might recognize that pattern. Of course, this is more for developers, but I will just go quickly through that. So here again, we have some blue part, which are the classes which you need to introduce in your integrating application. So there is this callback class, which needs to implement on event functions, similarly as with standalone integration. Through this function, you retrieve events coming from the navigation, like pass, waypoint, route finished, etc. And then there you have to introduce the service connection, which basically the important part is you need to define the on-service connected function, which is used to set callback and start the navigation inside a predefined window with some tedious programming. I don't want to go into detail. And there is this green part which I show that, which is executed at the initial phase, that is starting up of the application, where you need to set up or trigger the connection to the Sygic navigation, and it is again done with some tedious programming. There is you need to instantiate a connection class, then the intent class. You need to use the start service, bind service function, something you need to exactly know what to do. Finally, you also use onDestroy function, where you need to unbind from the connection. And in the brown part, I also show that you can encapsulate your full UI definition of your application exploiting Sygic API functions. Concerning layout, you have to also do something with the layout. So concerning the layout, you need to put the placeholder into your layout resource with the which is named. You need to name it surface view, and it has the ID which refers to some coding constructs, and you might have seen on the previous slide. So by introducing this kind of view, you basically position your navigation pane into your application. So so what does it take to migrate from 2D to 3D? It means that still using embedded integration, but now use Sygic 3D. So I have to say that the programming pattern for initialization has changed, but it is simplified. And we are here bringing a new Sygic fragment class, which encapsulates all this tedious stuff which you have seen in the previous, in the example. And so as a result, we think the code porting should be limited just a few lines of the code. So to kind of conclude how it could look like from the previous example to the new 3D example, it will look similar, but I think it will be more readable for developers. So you again need to define the callback class, which defines 3 on-service connected, on-service disconnected, on-event functions. Similar, this is very similar to standalone integration. Actually, this kind of brings us to more reminding of this standalone integration with respect to coding. And then you need to introduce the extension on the Sygic fragment class, which basically only provides where you need to only override the onResume function, which defines the callback, which actually points to the callback class, and starts navigation with just simple start navi command method. And if we look at the onCreate, how to trigger the connection, it's basically just 2 lines of the code where the fragment is instantiated. And this instantiation of the Sygic navigation fragment actually takes care of that boring stuff of initialization, starting service, binding, connecting, and all is done under the hood. Okay, and then there is also change on the layout you have to do. So instead of the surface view element, which you needed to incorporate within when doing Sygic 2D integration, now you have to introduce the fragment component and some encapsulating layout component, which refers with the ID to the source code, as was shown, as you might have noticed on the previous slide. Okay, so to kind of summarize the migration, I would say there are these few points you need to consider. So first, there is this change on the layout XML placeholder going from surface view to fragment. Initialization is changed, so there is the relative kind of complex binding to Sygic service occurring in 2D, while in 3D is just replaced with instantiating a new Sygic fragment class. Deinitialization, you need to do unbinding from Sygic service in 2D, while in 3D is automatic. You don't need to do anything about it. Then we have some syntactical flavor that we changed the register callback and start navigation to slightly different names, going from register callback to set callback and from run navi to start navi. But those two are called on the clear Sygic fragment class, which you instantiated. Then for the compilation process, building process, so in the 2D version, you have been provided with the Sygic drive jar file and couple of ASO libraries. Here in 3D, we just wraps it into one single Sygic lib AAR. You just build in your design. Concerning the file system, there are extra resources also differently placed. So in 2D navigation, you have 3 folders you need to manage: drive, res, and maps, while in 3D version, all is wrapped in the folder Sygic lib. Okay, so that was the second part, second type of migration, embedded migration. And now I have the last one, which is I call it the challenging, which is migration from having the standalone integration to embedded integration in the 3D version. And this is actually relatively simple, but it's with respect source code porting, because we actually took very similar initialization or interaction with Sygic pattern, which has been in the standalone integration. And of course, we have the same Sygic API call, so there is a compatibility 100%. However, you probably would need to redesign your application graphic user interface, because if you are going from a standalone integration, means navigation runs in the full screen, while here you want to change your graphical user interface in a way that you have your navigation on partially on the screen, and you have to squeeze your graphical user interface to the remaining part, or you need to rearrange it different ways such that it looks nice. And of course, you also have to be aware of consequences, as were pointed out by Victor already in the previous section, that the software updates are not that easy with embedded integration as with standalone. Standalone can be updated through just Google Play update procedure, while in embedded integration you need to do kind of deployment with your in-house mechanics. And the same applies to map updates. Okay, just to give you an idea what would be the code porting going from the standalone to the embedded integration. It looks very simple. Basically, you only need to add the Sygic fragment class as the way I presented. And you need just to change the initialization part from API init API connect to creating or instantiating a Sygic fragment. So as I said, the porting would be very simple, but the consequences are more wider. And this actually concludes my integration detail part.
Thank you. Thank you very much, Radim. So before we start Q&A, I have a last poll for today. We would like to know if you plan to make migration, when do you think this can happen? Leave a few more seconds for voting. Okay, I'm closing the votation, and as you can see, we will have some projects to do in 2016, look like. So now I would like to open the Q&A session, and I open with the question from Mattia Collati. We have answered a lot of questions in the chat, and I will be sending you this in the follow-up email. So the question from Mattia is, how does the licensing work for embedded? Victor, you will answer?
Yes, thank you. So the licensing currently is designed that it will work the same way as in the 2D navigation. That means that you have to distribute the activation code and the MLM file into the devices.
Okay, I hope it. Okay, good that we answered your question. And now we follow with the question from Martin. And he's asking, is it possible to pass a poly or multi-line to the Navi to define the route?
Well, this is a topic which is currently under development, so we hope that in a short time we'll be able to welcome you on another webinar where we'll be presenting this functionality.
Okay. And we have another question from Marius. He's asking, is there a way of being notified if the estimated time of arrival changes?
Thanks. So, for getting the ETA, we have added a new API functions into the SDK where it's possible to get a data structure that contains ETA to each waypoint of the trip. And currently there is no notification just when the ETA changes, because the ETA changes with every second. But with the new itinerary functionality of the 3D navigation, it is possible to define time windows or deadlines for certain waypoints, and the navigation provides notification in case that ETA to any of the waypoint gets out of the time window or behind the deadline. So you can be notified for changes in ETA that could be critical, but not to any change of ETA.
Thank you, Victor. And I think we answered now also the question from Bernd. Am I correct, Victor?
Yes.
Okay.
So it's possible to get ETA for each of the stops.
Okay. So if you have any more questions, just write. I will check the email. In the meantime, okay, we have another question from Sebastian. What kind of tachograph information broadcasts can we send? Probably. Is there a list somewhere?
So this is a new functionality. We have defined a data structure, and generally any application that is broadcasting this data bundle can send this, and that navigation, if knows the data structure, can consume this data. So we can provide you documentation. Well, and what kind of tachograph information? The only important information is the remaining drive time. That means what is the time till I have to make the stop. So this information can be sent to the navigation.
Thank you, Victor. Okay, we don't have any more questions right now. We are almost arriving to the 45 minutes of this session. So I will leave the session open for a few seconds more. If some question arrive, we will try to answer it. And if you didn't do so, you can download the presentation from the resources that you can see on the left up corner of the screen. And thank you very much for attending, and hope to talk to you soon. Okay, we have more questions. Jan is asking, is remaining driving time integrated in ETA calculation?
Yes. The ETA is estimated time of arrival, so the remaining driving time is the difference between ETA and current time. So this is also part of the data.
Okay, perfect. Thank you very much, and have a nice day.